like Unit 5 pumps. The hydraulic machine which converts the mechanical energy into hydraulic energy or pumps. The hydraulic energy is in the pressure energy. If the mechanical energy is converted into pressure energy by means of centrifugal force acting on the fluid, the hydraulic machine is called centrifugal pump. The centrifugal pump acts as a reverse osmosis for radial flow reaction turbine. This means that the flow in centrifugal pumps is in the radial outward directions. The centrifugal pump works on the principle of force vertex flow, which means that when a certain mass of a fluid is rotated by an external torque, the rise in the pressure in a rotating liquid head, the rise of pressure at any point of the rotating liquid is proportional to the square of tangential velocity of the liquid at that point. That is, rising pressure is equal to V squared by 2G. Differentiate between turbine and pump. Turbine is defined as a hydraulic machine which converts hydraulic energy to mechanical energy, thereby mechanical energy to electrical energy by using generators. Example, Delta turbine, Francis turbine, Kaplan turbine. Pumps are Pumps are hydraulic machines which convert electrical energy to hydraulic energy, where hydraulic energy is in the form of pressure energy. Example, centrifugal pump, reciprocating pump, submersible pump. Classification of pump. According to energy consideration, machines that supply energy to fluid, that is pumps, and increasing pressure takes place in pumps, fans, compressors, and propellers. Machines that extract energy from fluid turbines. A decrease in pressure takes place in turbines, windmills. Machines that are a combination of both energy transmitters and torque converters, shredded or unshredded, depending on whether the rotating lumber is enclosed in a casing or shredded in such a way that the working fluid cannot be diverted to flow around the edges of the impeller. Turbines, pumps are shredded. Aircraft propellers, windmill are unshredded. Based on direction of flow, we consider into axial flow, radial flow, mixed flow. Based on the manner of transmission of energy, kinetic displacement and positive displacement. Kinetic displacement, examples of centrifugal pump and turbines. Positive displacement, reciprocating pump. A pump is a device used to move gases, liquids, or slurries. A pump moves liquids or gases from a lower pressure to higher pressure and overcomes this difference in pressure by adding energy to the system. That is, mechanical energy converted into hydraulic energy is called as a pump. Pumps classification. Pumps largely classified into two categories: kinetic pump and positive displacement pump. Kinetic pump again classified into three categories: centrifugal pump, peripheral pump, and special pump. In centrifugal pump, three types of flows: radial flow, mixed flow, and axial flow. Peripheral is a single stage, multi-stage. Special pump, jet, gas, lift hydraulic, ram electromagnetic, and radial and mixed flow, single suction and double suction pump. Axial flow, single suction pump. In double and single suction pump as again classified into self-priming and non-self-priming. Then single stage, multi-stage. Single section pump is single stage, multi-stage. Then again it's classified into open impeller and closed impeller. Positive displacement basically classified three categories: reciprocating pump, blow case pump, rotary pump. Reciprocating pumps is divided into piston plunger and diaphragm. And then piston plunger is divided into double acting and single acting double acting pump. is divided into single rotor and multi-rotor. Single rotor vane piston flexible member screw. Multiple rotor gear low circumferential piston screw. And single acting, double acting pump divided into simplex, duplex pump, triplex pump, multiplex pump. And simplex pump and duplex pumps is again divided into stem pump, power pump. Pumps are divided into two fundamental types based on the manner in which they transmit energy. They transmit the energy to the pumped media, that is kinetic or positive displacement. In kinetic displacement, the centrifugal force of the rotating element called an impeller impels kinetic energy to the fluid, moving the fluid from pump suction to the discharge. Positive displacement uses the reciprocating action of one or several pistons or a sequencing action of machine gears, lobes, or other moving bodies to displace the fluid from one area into another. That is, moving the material from suction to discharge. Sometimes the terms inlet and for suction and exit for outlet are used. Applications of pumps. Pumps are used to deliver fluid at a higher elevation or at a long distance. To deliver fluid at a pressurized device for the control of hydraulic system and then drainage system, removing slurries, mud water, and irrigation purposes, cleaning, car washing, etc. We are using pumps. Centrifugal pumps. The hydraulic machines that converts the mechanical energy into pressure energy by means of centrifugal force acting on the fluid are called as centrifugal pump. Three important parts are in centrifugal pumps, that is impeller, volute casing, suction and delivery pipes. This is the cross-section of centrifugal pump. Centrifugal pumps important parts as impeller. This is the impeller, casing, this is the cover. This is called as casing or volute, and suction pipe and delivery pipe, outlet pipe, inlet pipe, suction and delivery pipe. These are all the important parts in the centrifugal pump. Impeller. The rotating part of the centrifugal pump is called as impeller. It is a rotating solid disc with curved blades. Impellers could be open, semi-open, or closed. This is the open impeller, and this is semi-open impeller. This is a closed impeller. For incompressible fluids, backward curve vanes are used. For compressible fluids, forward curve vanes are used. This is compressors. This is backward curve, radial curve, and this is the forward curve. Casing. Casing is an airtight passage surrounding the impeller which converts the kinetic energy of the fluid, leaving the impeller into pressure energy. Suction pipe is connected to the inlet of the pump and other side is dipped into the fluid in a sump. Delivery pipe is connected to the outlet of the pump and other end delivers the fluid at required height. Working principles of centrifugal pump. The impeller is geared onto a shaft which is mounted on bearings and is coupled to a motor which rotates the impeller. The kinetic energy of the impeller is transmitted to the fluid and its velocity increases. The volute casing converts the kinetic energy of the fluid to pressure energy. The pressure at the center of the impeller decreases as the fluid flows outward. The decreases in pressure causes the fluid of the sump to continuously flow through the suction pipes. The high pressure fluid is delivered through the delivery pipe. This is the diagram. This is the suction. Suction inverted and the impeller it's rotate and water will continuously to discharge. It's the volute casing impeller. This is again the diagram for impeller valve casing. This is the parts of the centrifugal pump. First, A is stuffing box, B packing, C shaft, D shaft sleeve. This is the sleeve, this is the shaft. E vane, and G eye of impeller, H impeller. This is casing rear, impeller, and this is the discharge nozzle. Priming. The pump casing must be filled with liquid before the pump is started, or the pump will not be able to function. To ensure that a centrifugal pump remains primed, most centrifugal pumps have footwalls installed or located below the level of the source from which the pump is to take its suction. Cavitations. If the suction pressure at the height of the impeller falls below the vapor pressure of the fluid being pumped, the fluid will start to boil. Any vapor bubbles formed by the pressure drop at the height of the impeller are swept along the impeller plates by the flow of the fluid. When the bubbles enter a region where local pressure is greater than saturation pressure, further out the impeller main, the vapor bubbles abruptly collapse. This phenomenon is called cavitation. There are several effects of cavitation. Cavitation creates noise, vibration, and damage to many of the components. They experience their loss in capacity. The pumps can no longer build the same head. The output pressure fluctuated. The pump's efficiency will drop. This is the effects of cavitation. This is the gap. This is the cavitation. This is the gap between the pipe and shaft. How to prevent the cavitation? Raise the liquid level in the tank. Lower the pumping fluid temperature. Reduce the NPSH required. Use a pump with a larger and impeller eye opening. Pump should be airtight. Friction losses should be decreased. NPSH, that means net positive suction head. To avoid cavitation in a centrifugal pump, the pressure of the fluid at all points within the pump must remain above saturation pressure. The quantity used to determine if the pressure of the liquid being pumped is adequate to avoid cavitation of the net positive suction head. The net positive suction if available is the difference between the pressure at the suction of the pump and the saturation pressure for the liquid being pumped. The net positive suction if required is the minimum net positive suction if necessary to avoid cavitation. NPSHA must be greater than NPSH or to avoid cavitation. Centrifugal configuration of pumps. Pumps in parallel and pumps in series. These are the both configuration in centrifugal pump. Pumps in parallel for high flow rate requirement, head or pressure developed is same as the individual pump. Flow rate is the summation of the individual pump. Pumping series for high head or pressure requirement, flow rate remains same as the individual pump. Head or pressure is the summation of two pumps. This is the pump connection in series and pump connection in parallel. This is the series pump and this is the parallel pump. See here, the one pipe is divided into two with the two motors. Here also one pipe connected with two motors. This is connected in series and this is connected in parallel at the same height. High velocity with high pressure. Motor can be raised from one level to a higher level in 2 days. High pressure and high velocity. High velocity method is very inefficient since the friction increases is proportional to the square of the velocity. High pressure method is efficient because of low friction. This is the characteristics curve for the centrifugal pump. Here, x-axis will provide discharge and y-axis efficiency and pressure or head or pressure. This is the characteristics curve. This is the efficiency curve, and this is the pump curve. This one is the system curve. Characteristics curve of a centrifugal pump. Specific speed. It is the speed of a pump with a discharging capacity of 1 meter cube per second and a head of 1 meter. Next speed is equal to n into root q divided by h power 3 by 4. A positive displacement pump causes a liquid or gas to move by trapping a fixed amount of fluid and then forcing the trapped volume into the discharge pipe. Periodic energy addition added energy forces displacement of fluid in an enclosed volume. Fluid displacement results in direct increase in pressure. Two types of positive displacement pumps, reciprocating pump and rotary pump. Reciprocating pump. In next class, we see in detail about reciprocating pump. Thank you.